Hi everyone, and this is the live demo of what our observability tools can do for you when your app is having some issues. Please note that the app version that I'm using right now is the app without any code support for observability. So the application is obviously login into standard output, but there is no code in the app that does tracing or exposes additional metrics or anything like that. So let me hit our app with a series of GET calls with HTTP, and as you can see, this is the expected answer. So the entries on our to-do list in our to-do app, but sometimes our requests fail. And also sometimes, if you pay attention, sometimes some requests take much longer than the others to get response, okay? So definitely there's something going on with our application, and we can head to Linkerd's dashboard to see what's going on. And at the first eyesight, we can already see we have two issues over here. Let's try to use our observability tools to discover what is going on with our app. First issue we can see is that our success ratio for API server service is well below 100%. It's around 90%, while for the to-do manager, it's 100%. So we can already expect that within our whole microservices architecture, API server is misbehaving. But also please have a look here. P50 latency, so basically 15th percentile, half of the latency distribution is very low at 5 milliseconds. But already P95 and P99, so upper range of the distribution. So 95% of requests is faster than 200 milliseconds, but 99% only than 3.6 seconds. This is already a very long request, much longer, like almost 1,000 times longer than this request, which is P50 latency. And if you will have a look at To-Do Manager, it basically looks the same. So most probably it's the To-Do Manager service that is responsible for introducing this delay. We still have to confirm it, but because this data is very much in sync, it's probably the To-Do Manager introducing delays. So we need to check both. From here, we can move to Grafana and check how does it look like there. In Linkerd dashboard, we've seen live data. Over here, we see live data, but also historic data. So you can see that the latency was pretty much always like that. So since the problem started, it's not getting worse, it's not getting better. P99 is really high, around 3-4 seconds. P95, the yellow line, well, it depends. And the success rate for API server, yes, it is falling down to around 90%. Okay, we haven't learned much more from here. So let's use another tool. Let's switch to logs. So we go to logs, to log key. And from over here, we can choose all the logs that were produced by our app that is named To-Do API server. But as you can see, there's not much over here. The messages are rather cryptic. If we expand one of the messages, we can learn more. We can learn about the attributes that are associated with this log entry. We see over here a user agent and the protocol, but well, not much more. Let's try to figure out something. Let's see if we can at least learn what HTTP error codes are returned. So we expect that the problem, okay, let's see what other user agents we have. Let's exclude my curl that is running in parallel in terminal. Okay, so now we have requests without curl. What do we got over here? User agent is Prometheus. Okay, we probably don't want to see requests from our monitoring service. Let's check another one. User agent is Kube Probe. Yeah, Kube is checking health checks for the app. Let's exclude them as well. Okay, and now we are basically empty. So now we can restore all other requests. Okay, so now we have requests that exclude those from kubeproxy and Prometheus. We are basically left with user requests only. And also let's have a request complete message. The request complete message has information about status code, and this is a successful request ended with 200. Let's exclude them. So let's try to figure out what unsuccessful response codes are. Well, additionally, response codes are associated with request complete methods only, because only then we know the actual code. So we want to go for request complete text in the log message. Let's run the query. Sorry, we need to do a string over here. Yep. And let's have a look. So the status is 500. Not very informative. Okay, there was a failure on server side. Okay, it seems all of them are 500. So yes, we have logs. We haven't learned much, but well, still we can investigate them. But still we have one more data source. So as you remember, we also have Jaeger running for our installation. So let me set up a port forward for our Jaeger server, and let's head over to Jaeger. I will ask Jaeger to present in the UI a little bit more than just last 20 results. Okay, so here we have last 50 results. We can have a look at any one of them. Let's click over here. And yeah, this is already quite informative. So as you can see, we have like two separate parts that look like they are unrelated, but that's because our app is not doing any actual tracing. So what we have over here is a single request that started at Nginx ingress controller and then moved through Linkerd proxy to our API server. And then API server is doing another call, but this is a new call, a call that API server is starting through gRPC to the to-do manager service. So here is that new another second call, and as you can expect, this call is actually a subcall of this major first one call, but they are shifted on the graph because clocks are slightly out of sync. So the clocks between services are slightly out of sync, but we can already see that the whole request took like 7 milliseconds, out of which around 5 were spent in API server, and then another around 2 milliseconds in to-do manager. We can't really see the app over here because the app is not instrumented. This is what we get automatically from Nginx and from Linkerd, but we can already see something over here. If we return to overview, over here you can see the distribution of time of your traces, and you can clearly see that some of them are higher, way higher than the majority. So let's dig over here, and what we can see over here is that this request that took 3 seconds to complete spent those 3 seconds to the very bottom of our call stack. So the last service in our call stack is to-do manager, and specifically the least to-dos request that we can see over here. And it's that request, the least to-dos request, that took 3 seconds to complete. Okay, so we learned something. Definitely least to-dos method in the to-do manager service is very, very slow sometimes. Additionally, if you have a closer look, some of those low value, low delay requests are also a little bit higher than the others. Let's have a look at such request. Okay, and we have another interesting fact over here. It seems that sometimes also it's the API server that gets slow. Not as slow as to-do manager can be, but it's around 100 milliseconds. Okay, and it's definitely before the request is sent to to-do manager for listing to-dos, because that takes like 4 milliseconds. And even before that, we've spent another 100 milliseconds inside the API server service. So all this information, all those data we got from our application for free. We are just using the observability tools that, combined with proxies of a service mesh, allow us to do investigation like that. Without instrumenting the application, we won't learn much more. So my application is prepared to actually run as both instrumented and non-instrumented version. So let me now turn instrumentation on, and let's see what's gonna happen then, how our investigation will look different and what we can learn. Okay, so we need to flip this config option over here to true, and let Kubernetes restart our pods with the new config. Let me stop doing calls for a second. We'll start them again. Okay, the pod is already terminating. We should be good to go. Let's hit it with requests again. So let's start over. Let's see if we can learn something more. Over here, nothing really new. This is what we get from automation related to Linkerd and its proxies. So again, we see basically the same thing. Let's move to Grafana. In Grafana, we were checking the dashboard, but the dashboard was coming from Linkerd, so there are no changes as well. But now my application is exposing some custom metrics as well. So I can go to this graph, and as you can see, we have custom metrics graphed in a custom dashboard, and I can already learn something from here. I can see that, sure, I'm getting 500s. They are all for the GET request. So either there is very low amount of posts, or there are no posts at all actually, but gets end with either 200 or 500 code. Currently only one user is using my application, so I can get some graphs per user, and I see that my user Anonymous is doing like 3 requests per second right now for the get all to-dos, which I expect to be quite heavy call. So probably the errors I see are generated by this user. And the important and really interesting part over here is this request response time distribution. This is a heat map. So basically each vertical bar shows us the distribution of response time at this time period. So I can see already over here that I had like 90 requests that were below 300 milliseconds, and over here there were 2 requests that were below between 1 and 2.5 seconds. Okay, so yes, this confirms what we basically already know, that some part of our requests are really slow and tend to hit this distribution, this delay between 2 and 5 seconds probably, but this is clearly visible over here. We are basically good because majority of our requests are very snappy, but yes, some of them are really slow. So okay, let's try to learn something more. Once again, let's go and try to figure out from logs what is going on. As you've seen, logs were not very useful before, but now we have one helper over here. We just need to find the correct logs. So we want request complete logs. Right, now we have only request complete. We want to filter out successful ones. Okay. Yes, this is a request that has ended with HTTP status of 500. But the interesting thing over here is that we have trace ID. So my application is now actively doing tracing. Let's try to use this information to investigate traces as well. So we switch to Jaeger and we want to look for a trace with this ID. Grafana is offering traces integration for quite some time already. As you can see over here, we seem to miss part of the trace. It's probably the request was still the old one before I restarted the service. Okay, it's because yes, the service is well restarted, and we need a few seconds for Loki to pick them up. We can make this faster if we restart Loki pods and basically force them to reload the configuration. I'll get back to this in a second to show you how you can use it right now. Let's see if we can already get something fresh. Not yet. Okay, we'll get back to it, but let's also ask Jaeger for new traces. Okay, so as you can see, our traces look very different now. We don't only see the automated parts of our tracing infrastructure, so Nginx and Linkerd, but also we can see our API server, which is clearly marked over here right now, and we see how much time is spent servicing the incoming request and doing the outgoing request to list to-dos. But also what is important, the to-do manager service shows us the exact span it needs to execute the query, but also there's a mark that shows exactly how much time was spent doing a request to a database. And this is obviously one of the good requests. So let's try to see how does a wrong one look like. So again, we have something very high over here. And this is the long request. We've seen that already before, but now we can confirm with 100% certainty that it's the database that is really slow. So not the to-do manager service itself, but rather the DB list operation, so listing all the to-dos from the database. This is what takes 3 seconds sometimes. So we have quite pinpointed the problem here. We need to check what's going on with the database, that sometimes it is responding in a range of single milliseconds, and sometimes, like over here, it takes a few seconds. So that's a success. We have successfully investigated one problem. But also let's have a look at this request. Again, this is what we've already seen, but now in more detail. So we know that there's a request coming to V1 to do that takes around 100 milliseconds. But then before API server actually makes this, so starts the request for list to do's, it is somehow spending this 100 milliseconds inside, and it's usually not doing this. So if we have a look at some other call, like over here, it is usually very, very fast, 5 milliseconds, so 20 times shorter. So we have successfully identified two problems, right? First one is that our database can be slow sometimes, and second, that our API server, before sending a request to the to-do manager service, can introduce around 100 milliseconds of delay as well. And as I promised, I'm getting back over here. New logs are already in. We can get again a trace ID. And if you know that this trace ID is exactly the case you want to check, you can directly check it over here in Grafana. So this is a new option from Grafana. We are not really lucky trying to get a request over here, but that's expected sometimes because this is asynchronous. Everything is asynchronous, so every part of the tracing stack is sending spans that it is recording asynchronously. So sometimes for a single trace, we already have reports from one app, but not yet from the other. This happens. We can try another one, but we've seen already in the Jaeger UI that full full tracing, full information is stored within the database for the requests that are running in our system. Okay, so I can't really find a request like that right away in Grafana, but still those requests are definitely correct and complete, as we've seen here in Jaeger. Okay, thank you very much for your attention. If you want to ask some additional questions, please reach me. You can find contact to me on the company website. Thank you very much.